Welcome back, everybody. This is going to be a part 2 of our home review for lesson 34, solids and their cross sections. These last questions deal with not prisms, but this solid called a sphere. And the sphere is defined as being a collection of all points equidistant from a fixed point in space. So we've seen spheres before, whether a shape of a ball or a globe, and and again, the idea is that all these points a given distance away from a center point, and moving in 3 dimensions, if you will. And we're going to be doing a lot of 3-dimensional material in higher level math, and because we live in a 3-dimensional life and also. So now the question here is going to be the following: the definition of a sphere is a 3-dimensional version of the 2-dimensional shape. Looks like a circle, because it starts off looking like a circle. Now, does it kind of make sense, right? So 3-dimensionally, it's going to be a 2-dimensional shape of a circle. Now, if we were to take a cross section, and I'm going to use my green dot line, if I were to cut the sphere going this way, or even going across horizontally, or even a diagonal, no matter where I cut this, I can imagine there's a big spherical cake, if you will. All right, where I cut it, the cross section I'm going to see is definitely going to be, in this case, you guessed it, a circle. Okay, so there you go. They're both going to be circles. And so again, how the cross section would be, if I slice off a piece of the sphere, what will be revealed as a shape underneath? Okay. And now for our last question, very short part 2. Maybe I should put everything together. Okay, question number 8. A sphere can be created by rotating a circle about what line or line segment must the circle be rotated to order the sphere? So we're going to be creating now, in this case, so let's take a circle. All right, and actually going to, first I'm going to put down our center. And then I'm going to draw for us a circle here. So here we go. All right. Now, here's the thing. Around what line segment or line? So if I was, so we go back, like, what if we drew our line going, I don't know, here? Well, we rotated, we would probably not get our circle, if you will. So it would kind of a weird shape, if you will. It can't be this line. So, and it's got to be, and there's got to be some line that specifically, and I think in this case, to be able to get a sphere, you're going to have to go through the center. All right. So in this case, if we use this green line, let me make sure I go through the center here, right there. There you go. If we rotate the circle about a line going through the center, we're going to rotate, we're going to get the shape of a sphere. So what line or line segments would be, we're going to call this the diameter of the circle. Okay? So we would have to go through the diameter of the circle to be able to find in this case, create the sphere, if you will. So taking us to rotate the circle about the sphere, about the circle's diameter, and spin it around, we're going to create a 3-dimensional object of the sphere. Okay, so it has to go through the center, ladies and gentlemen. All right, you actually have one question, question number 9. This one's interesting. And so it says here, in the circle below, if the circle below is rotated about the line shown, what type of solid would be produced? Hint, this time not a sphere. So here we have the circle, okay? And actually, if we were to take this circle and to clone it, let me clone the circle here. Okay, and so now I'm going to move the circle. So it goes all the way around and around and around and around and around and around and around. Come back around again. So it's rotating this way. So it kind of like is not going to be a sphere, okay? What it is tracing out, ladies and gentlemen, is going to be the following. So I'm going to put this over here. All right, so you can see this. And so we're probably going to get, going all the way around and around again. that's going to look like, well, a donut. Okay, now I believe the correct term is a torus. Okay, I believe it's a torus, T-O-R-U-S. Okay, but you know, it's kind of like it, but I think I mean that's I think the technical term. However, I rather refer to it as a donut. Now, donut can be spelled with donuts or donut abbreviation, like Dunkin' Donuts, no. And I would like to think of it this way because, well, it's a much tastier type of figure to talk about, ladies and gentlemen. So here we go. We're not going to get a solid here. That's going to be a sphere. Instead, just rotating about a line that's not going through the center circle. There's going to be a big hole in the middle. Okay, so that's like a donut. All right, that's the shape we get here. So, ladies and gentlemen, all right, hope this was helpful. All right, this is our last questions of homework and all. And so just to kind of get a good understanding of solids, okay, trying to imagine these things, if you will. So, and a funny thing is, if you took a donut and you just cut down the middle, you would get a cross section of a circle, right? If you were to cut down, I would say in this case, going this way. Oops. Maybe a little straighter than that. All right, let me, a little straighter. How about if I use one of my straight lines, if you will. Here we go. I want to use this one. If you went through here, okay, cutting, in this case, cutting up and down, meaning cutting up and down here, slicing through the donut, if you will, you would get, in this case, a circle, okay? So this figure is going to be called, I'd rather just call it donut, okay? I'd rather call it donut, ladies and gentlemen. All right, so hopefully this is helpful. If you have any questions or comments or suggestions, please leave in the comment section below. Thank you so much for watching. Please leave a like to the video, and of course, make sure that you subscribe to the channel to be notified when new videos are going to be added. All right. Thanks so much. I will see you in the next video. Take care and be safe.